local development environment. So I'm going to talk about your development environment, your testing environment. I'm going to talk about some dependency workflows. We do something kind of interesting with the package index that I think a lot of people could emulate. I'll talk a little bit about linting and auto formatting, and then finally about how to take your environment and go to production as well. So some things that I'm not going to talk about. Things like editors, operating systems, platforms, other kind of like religious debates. So these are deeply personal things, right? And your choice of a code editor should have no effect on your teammates, right? It's just the place where you write code, it lives on your machine, it should be whatever you want, right? That's your choice. What I am going to talk about is anything that you're going to check into your repository, anything that's going to be shared between you and your teammates, right? Now that's sort of where the line is, right? There's the stuff that you do locally on your machine, that's fine. And then there's the stuff that you're going to share with your teammates. So one quick caveat is the difference between an application and a library. So I'm mostly going to focus on applications, and I'm specifically going to talk about web applications. Developing a library or developing like a Python module or package is a little bit different. And trust me, there is a difference between the two. I'm going to focus on applications. If you're curious about developing libraries, I can talk to you afterwards about that as well. So this means that we're going to assume that there's this application is going to run under a single version of Python on a very specific platform. So your local development environment, this is when you say, but it works on my machine, right? If you get it working on your machine, that's your local development environment. The thing to note is your laptop is not production, and it never will be. You can't take your laptop and put it in production. So even if it runs on your machine, it needs to be able to go from your local development environment to your testing, staging environment, and then all the way to production. We need to find a way to do this. Because the problem is literally anything in these environments can cause inconsistencies. It can cause differences between the environments. They can raise bugs. That can cause issues with deployment, with database migrations, all these things. All these things cause problems. Here are some things. SSL certificates, etc hosts, differences in OpenSSL, global dependencies. Having your machine set in different time zones causes really weird bugs that are really hard to find. So all these little tiny inconsistencies can cause huge problems. So here's one that happens all the time. Let's say you have a requirements.txt file. It has two packages in it, foo1 and bar 0.9.9. So this is great. We can pip install it. It successfully installs those. This is good. You can have those locally. When you run pip freeze, you have them. Great. They got installed correctly. But then what happens? Your coworker says, hey, check out this cool unrelated library that I just found on our Python. So you say, okay, cool. I'm going to pip install this unrelated library. And what you don't realize when you're installing this is that unrelated library requires a newer version of bar to exist. And because Python, you can only have one version of a package, and everything is in this global scope, it automatically surprise upgrades bar. So when you pip freeze now, you have bar 1.0.0 instead of 0.9.9. And now you have a newer bar in your environment, and this could maybe cause problems when you go back to do your actual work, and your program isn't ready to use this new version of bar. So this can cause a whole bunch of issues, and it's really hard to figure out. And you might say, okay, that doesn't affect me, because I always use virtual environments, right? Who uses virtual environments? Yeah. Do you also always deactivate your virtual environments? No, probably not. I always forget to do this as well. And then the same thing happens. So the thing to note is that virtual environments, they only isolate Python. Anything on the platform level, anything on that huge list of inconsistencies that I mentioned before, that's still shared between virtual environments, right? They let you isolate Python packages, but nothing else gets isolated. It's still running in the same platform, the same environment, everything else. So virtual environments are good. I'm not saying don't use virtual environments. But for this example, for local development and taking it to production, they're not enough, right? You can't take a virtual environment and deploy it to production. You can't take a virtual environment and put it on your coworker's machine either, right? So what if we could fully isolate our environments? This means that you and your coworker could use the exact same environment, like bit for bit exactly the same. And that environment was reproducible. So even if they didn't have it, they could reproduce it exactly the same bit for bit, and it would be the same environment on both your machines. And what if your coworker doesn't use the same platform as you? What if this worked across any platform? It doesn't make a difference if you're on Windows or on Mac OS or on Linux. So I don't know if you heard about this before. This is what Docker is. This is also called containerization. that allows you to run a container on any platform, on any operating system that is reproducible. So for example, these containers, you can define them yourself, but there's also what we call base images as well. So for example, there's the Python official Docker image, this base image. And if you run this on your machine, you get basically a snapshot of a specific version of Python and everything you need to run Python. So if you have Docker installed, you can run this command, Docker run Python. Python is the same, the name of the image that we showed in the screenshot before. And what this gives you is a Python REPL. This is just like running Python on your computer, except it's inside this isolated environment that has nothing else in it, right? So we can also run arbitrary commands. We don't have to just run Python. So I can just run a bash to get a shell here. And then I can run pip freeze. And you can see that because this is a pure, pristine environment, there's nothing in it. The base Python image just has nothing at all except for Python. So I can install things. So I can install Flask. And then when I pip freeze, all those things are there. And they'll stick around as long as I'm in this session. However, if I exit it and go back into it again, everything's gone, right? Nothing has been changed. And the thing to note here is that basically a container offers no persistence. You can write to the file system, you can install packages, but once you leave that container, everything goes away. Okay, so what use is that, right? The only way to change a container is to create a new container that derives from it. So we start with a base image, and then we can do mutations to this image, to this container until we get what we want. We can install a package, and then we get a new container. We can install some platform dependency, and then get a new container. So I'm going to show a very simple example. This is the Hello World Flask app, just a single endpoint that says Hello World. This is a requirements.txt file. All it does is install Flask. And then this is the Docker file that we would write to create a Docker image. It says from Python. This means that we're inheriting from that official Python base image. Copy. Copy moves all the files that are on our local machine into the container. So it's copying the requirements.txt file and the app file. And then run. Run lets us run arbitrary commands that mutate the container. So here we're going to run pip install requirements.txt, and it's going to install those requirements. So we have just these three files. They all live next to each other. And then we can build a new container. So you can see here in each step, 1, 2, 3, it's running each of those commands. From Python, starts with the base image. Copy gives us a new image. Pip install gives us a third image. And then finally, that's the last command that we have. And so we have a new container that's been built. And I just called it my container, and then it just tags it right down there. So then I can run this. Instead of saying Docker run Python, I can say Docker run my container, and I can get a shell. And then when I pip freeze, everything is already in there. The container's already been built, the dependencies have been put in it, and I'm ready to use it. So what can we do with this? Well, what about running our application locally? So Docker is just a primitive here. We shouldn't need to manually run Docker build and Docker run, etc. So instead, we're going to use a tool called Docker Compose. And this is a tool for defining and running applications that use multiple Docker images, but it's okay to use them for just a single image as well. So Docker Compose is configured like this. Ignore the version here. It's in a file called dockercompose.yml. And we're going to define multiple services here. So this service is going to be called web. It's going to be built with the local directory, which is going to have that Docker file that we just created. It's going to expose a port. This means that traffic from inside the container is going to be mapped to our operating system. And then it's going to execute a command. So here the command is just flask run, and it's just going to run that web application that we created. So then I can run a command like docker compose up, and that does all the building for us. It's the same results from the build command that we ran before. And then it actually executes the flask run command that we created. So then inside the container, it's running the Flask app, and it's mapping the traffic on port 5000 from inside to outside. So then on my local machine, I can go to localhost 5000, and I can hit the container inside. I can hit the application that's running inside. So you might say, maybe you actually need multiple containers, right? What about data storage? Maybe your application needs a database. So with Docker Compose, you can just continue adding new services. So for example, if it needs caching, you can add the official Redis image. If it needs a database, you can add the official Postgres image, and your app will just be connected to a fresh, empty database that you can do anything that you want with. Okay, so that's great for running our application locally. What about everything else that we need to do? What about testing? So we've created this perfect environment that has all our dependencies, everything set up and ready to go. We should probably run our tests in that same exact environment as well, right? We don't want there to be inconsistencies between our local development environment and our testing environment in the same way we don't want inconsistencies between our local development environment and production. So we can run this command with Docker Compose. Docker run PyTest, for example. If you use PyTest, that runs PyTest inside that same container. And it's as simple as just adding some tests and the PyTest dependency. And so on the Python package index, we use kind of a nice thing to abstract away the Docker Compose even. So we use makefiles. Has anyone used makefiles before? They're kind of like an old technology that I think is still really relevant and pretty useful. They're not super popular, but what we do is we sort of wrap all the Docker Compose commands in really simple make commands. So the first bit here basically ensures that we've only built everything once. So it creates this little file that's sort of like a flag. And then each of the commands depend on the build succeeding. So we can run make serve, and we can get it runs Docker Compose up. We can make tests, and it runs PyTest for us. So all you have to do once this is set up is run make tests. It runs Docker Compose web PyTest. That runs PyTest inside our container. And all of our testing happens inside this isolated environment, right? And this environment is exactly the same as the environment that we're running the application in. And make serve is great as well. You can just run make serve, and everything just comes up quickly and immediately. So when you test in the same environment, it means there can be no inconsistencies. You don't have flaky tests. You don't have one dependency in one environment and a different one in another environment that causes inconsistencies in your test environment. But the other advantage to testing in a Docker Compose environment like this is it means that you can have true integration tests, right? When I added a database to my Docker Compose earlier, I can use that in my tests. And actually, the tests that we have for the Python package index, a lot of them actually use the database. They make sure that when something happens, something gets put in the database, and we can test against what is actually in the database. And each time, for each individual test, we'll create a new database session that's empty to ensure that it's completely isolated. So because we're using Docker Compose to isolate these environments, it means that we can just reuse and get a new database every time and reuse it in our tests and have actual integration tests that use the same database, not a fake database, that we actually use in production. So here, Compose will abstract away Docker, so you only have to write a single Docker file, and then you can reuse it for multiple things like web and test. And make abstracts away Compose. So it simplifies the commands that you need to run, makes them easier to remember for your developers. This can all be summarized as optimizing for onboarding. So just because you know how your application works doesn't mean that someone else does. You should make it as simple as possible for someone to come with zero knowledge of what you're doing, get onboarded, be able to run your stuff locally. With PyPI, you can run a copy of PyPI locally in like under 5 minutes. It's super easy. And the thing is, it's not just for new people joining your project. Like, your laptop gets stolen, you're going to need to onboard yourself, right? Yeah, so it'd be nice if that was easy for you as well. It just makes the overall developer experience better. So here's your new onboarding document. Install Docker, run Docker Compose up or make serve, and then you're done. That's it. That's all you have to do. Okay, so another interesting thing that we do with the package index is sort of what I'd say is a modern dependency workflow. So there's lots of options here for how to manage Python dependencies. But basically, this is a way that you're never going to have to edit a requirements.txt file ever again. Okay, so have you ever done this? Pip freeze, pipe that all into a requirements.txt file, done. Who's done this before? I've done this before. Yeah. Don't do this. The reason you should not do this is because when you do that, you get everything in the environment. You don't just get the dependencies that you think that you want, that you have just recently installed. You get every dependency that you've ever installed all the way back to the beginning of whatever that environment is. So yeah, maybe you pip install Flask and you freeze. When you freeze, you just get everything that's listed there. However, there are some advantages, right? There is some reasons why you would want to do this. So one of them is version pinning. And this ensures that you don't get surprise updated one day, right? That was the example way at the very beginning. So version pinning is when you say like package double equals a version number. This ensures that every time that you install that package, you're getting the same version. The other reason that you might want to pip freeze and put that in requirements.txt file is to manage sub-dependencies. So all you want to do is install Flask, but Flask needs all this other stuff too, and you don't know what those are, and it's hard to determine what they are. The easiest way to do this is to just install Flask and see what gets installed, and then store all those things in your local environment. But you don't want to have to think about all this. You don't have to think about all these individual dependencies. So the tool that I'm going to suggest that you use kills both these birds with one stone, and that's a tool called pip tools. So this is not like a new tool necessarily. These are like little extra workflows that work on top of pip. They just use pip under the hood. And the most useful thing here is what I'm going to call compiling your dependencies. So instead of creating a requirements.txt file, I'm going to create a requirements.in file. And all it's going to have is Flask. It's not going to be pinned, and there's going to be no subdependencies. And then I'm going to run this command, pip compile requirements.in. And what that does is it produces a file that looks like a pip freeze file, right? It has our versions pinned. It has all the subdependencies. It even tells you where the subdependencies came from. So I know that markup safe is getting installed because Jinja 2 is getting installed. Jinja 2 is getting installed because of Flask, right? So I know exactly where they're all coming from. And you never have to touch this file. This file gets automatically generated, and it is only generated from the dependencies listed in the in file. It's not based on anything in your local environment. So you know that there's not going to be extra dependencies getting installed here by accident. This is really useful. I'd recommend everyone uses this. However, pinning and compiling actually only gets you about 90% of the way there. So if you go to the Flask page on PyPI, you'll see that there are 2 files available to download for a version. And this is true for most Python packages. However, for some packages that aren't just pure Python, that have C or other things, they have to produce a lot of different artifacts. So what you install is actually dependent on your operating system. And what happens is all these files have hashes. And the hashes is a security mechanism. It ensures that the file that you're downloading from PyPI is the same one that was originally uploaded. So this is called artifact hashing, and it basically is a tool for making sure that what you got is what you actually meant to install, or what you installed the very first time. Pip has a tool, has a mode called hash checking mode, and this means that you can install and require the hashes to be specified for all of your dependencies. This solves another really subtle problem, which is that sometimes Python packages, they'll publish a single file, and you'll pip install it, whatever, and you'll put it in your requirements file. And then maybe like a week later on this new release or something, they'll add some of these more platform-specific files. And what you'll be installing will actually change, because what pip does is it picks the best file for your operating system. So if it's just a source file, you'll always get the source file. But if there's more specific distributions available, it will install those. However, when you require hashes, you're ensuring that you're getting exactly the same package. Even if there are newer versions available, even if someone has compromised your network and they've inserted some malicious package in as you're trying to download it, it's going to fail. And the hashes will ensure that it always works. So when you require hashes, it requires that your requirements file looks like this. And so this specifies that for Flask, there are 2 possible files that you can download, and these are the hashes of them. This is annoying to update. You don't want to have to go to PyPI and find the hashes for each of these. So you can use pip compile also to generate hashes. So this is the same command from before with a generate hashes, pip install require hashes. This creates a file like this. Has all these hashes in it, has everything pinned, has all the subdependencies. You never have to look at this. You never have to touch this. However, now that your dependencies are 100% frozen, if you don't touch this, how are they ever going to get upgraded, right? When should you upgrade? You should upgrade your dependencies early and often. You should try to do it as when a new release comes out, you should upgrade. You don't want to get behind. The way you should do it is with an automated dependency management service. You shouldn't ever have to go look at PyPI. Oh, look, there's a new version. Okay, I'm going to go edit this file. That's 2009. Don't do that. So there are services. There's one called PyUp, pyup.io. And there's another one called Dependabot. I'm going to talk about Dependabot because that's what we use. So what it does is it makes automated pull requests against the repository. And it says, hey, there's a new version of SQL Alchemy. I'm going to bump it from 1.6 to 1.3. Actually, this is skipping over one, but yeah. And so what it does is it automatically makes a change to the main or the requirements file. So it's going to upgrade the version pin, and it's going to upgrade the hash as well. And the other nice thing that this does automatically is that because this is working across multiple Python repositories that have the same dependency, it can tell me the compatibility. It sees whether the tests have passed for all those other PRs that it's made, and it can say, yeah, I made 6 PRs, or I made 8 projects upgrade this dependency. Their continuous integration passed 100% of the time. You should feel like you can upgrade this without having to it's not going to cause problems. This is a really nice feature. One last thing I'm going to talk about, linting and auto-formatting. This used to be a long and endless discussion about which tools you use, what code style you want, all these other things. We're lucky, we're in the future now. All you have to do is use black. Just use black. So black is a opinionated and uncompromising Python code formatter. It's not customizable. It makes one choice about the way that your code should work, and it will automatically format it to match that. You have to run it once, everything gets auto-formatted, and then you never have to think about code style, about PEP8, about any of that stuff ever again. It works really well. And basically, I'm going to summarize this tweet that was from a recent conference. Consistency is better than your personal preference. Even if you have a personal preference for the way your code works, you should just use black. It's easier, and it gets rid of this whole class of arguments about code style and about code quality. Black works like this. You give it a file, it auto-formats it, and then it's done. You get cake too. And on PyPI, we also have a makefile command for reformatting. So all you have to do is run make reformat. It runs black inside the container, again, in the same environment, reformats all the code. So this makes me a really bad Python developer because I just write really ugly Python code all the time because I know at the end of the day I can just run make black and it will look perfect and no one will know. All right, one last thing, taking your environment to production. Because at the end of the day, that's really our job, right? We can only do so much locally, but we can't actually serve traffic from our local laptop. So I just taught you how to build a local environment that's reproducible, that you can share between your teammates. Why can't we take this to production as well, right? And the truth is that we can. So a lot of the big cloud providers, they offer a way to take a Docker file or a Docker image, that the same image that you would use locally, and deploy to production environment. So for example, Heroku has a deploy with Docker service that you can deploy a Docker image. AWS has the ability to deploy Docker containers to ECS. And since I work for Google, I'm going to tell you about the Google one too. This is a service called CloudRun. So it's basically a hosted Docker container. You build a Docker container, you deploy it, and then it can respond to traffic. This means that you're not stuck into a specific programming language or specific runtime, right? You can create code in any programming language and use any base image as long as you can write a Docker file for it. So this means that the world is like, people can write like Fortran, whatever they want runtimes, as long as it listens on the right port and responds to HTTP traffic, we don't care, you can deploy it. So if I was going to take our example from before, where we have inherit from Python, copy our files in, install our dependencies, if I wanted to deploy this to CloudRun, all I would need to do is add a command. This tells us what to do when we're deploying the container, how to start our server. So this command is this is the same one that was in the Docker Compose file actually, and it's just flask run, and it listens on a specific port that's provided. With Google, we can run gcloud to build the image, and this will upload it to the Google Cloud Image Registry. So this is just the same as running Docker build locally. And then we can deploy it. And once we deploy it, we get at the very bottom here a URL. And this URL is out in production. And you can use your own host name as well. But basically, if you click that link, it's the same application. You're running in the same container that we did locally. It's identical. It's exactly the same. So this is really powerful because it means that we have eliminated any inconsistency between our local environment, our coworkers' local environment, our testing environment, our linting and auto-formatting environment, and our production environment. They are all exactly the same. Cool. All right, so in conclusion, I want you all to start doing a few things. First, use Docker to create reproducible environments. Virtual envs are good. You can use them locally to test certain things here and there. But I think people can start to use Docker when they're defining web applications and services that they're going to share with teammates or with other open source contributors, et cetera. However, you should use Docker Compose to build services out of Docker containers that mirror the way your production works. That includes databases, that includes Redis, all that other stuff. You should absolutely use pip compile to pin, compile, and hash your dependencies. Hashing is not a requirement. However, it's a nice security feature that you don't want to get bit by someday if you're not using it. Also, use PyUp or Dependabot to automatically manage all these dependencies. You should never have to be editing a requirements file. You should just let the bots do it for you instead. 5, use Black. Throw away all the other linting and auto formatting tools. Just use Black. It's the best thing out there right now. And last, use all these services provided by the cloud providers to deploy your Docker containers to production. This is going to solve so many deployment issues and inconsistencies, and it's really the modern development environment and workflow. Thanks. Do we have time for questions?
Yeah. So we have time for questions now.
Okay, any questions? Yeah.
Well, so you mentioned pip tools. Pip is a great feature for pinning dependency. Why not integrate pip tools inside the pin officially?
Okay, that's a great question. So the question was pip tools, and there are other things that pip tools have as well. I think pip compile is probably the most powerful one. But the question was, why not take all those things in pip tools and integrate them into the regular pip, right? And so the idea is that pip tools is kind of a way to experiment with some new workflows that aren't necessarily provided by pip as an official method. So basically, pip has millions of users. And so anytime that we make a change or add a new feature, immediately gets depended on by tons of people, and it has to be right? There's a huge potential for issues if we haven't totally figured it out, because basically, as soon as we introduce it, it's going to become really important to someone's workflow, and we can never change it. So tools like pip tools allow us to sort of experiment and try new things. This is a relatively new pattern. I don't think a lot of people have. Has anyone like compiled dependencies like this before? I don't think so. It's all right, a few folks, right? Yeah, so this is also a little similar to what pipenv does as well. And pipenv is also like a kind of a little bit of an experiment as well. Like the lock files and things like that. So this is a kind of the equivalent of a lock file as well.
Yes. And another question is, the maintainers of pip tools was or is the Jazz Band group?
Yeah.
Yes, okay. And the last one, is it possible you answer? PyP is planning to use in some future GitHub to download the storage of the dependencies and manage the source code?
This is the question, will PyPI use Git repository?
GitHub, like Node.js, NPM, use GitHub to download dependencies.
Yeah, so are you talking about the new package registry?
Yes,
yeah.
In the future, will you use GitHub too?
Okay, so right now, actually, and I think this is the same true for JavaScript. The question was like, can you install from a Git repository or the new package registry?
Yes, I know it's possible you install from GitHub,
yeah.
But the tendency of the package manager, we focus in GitHub.
Yeah.
So PyP have plans in the future to use GitHub too?
I'm not sure anything's really going to change there. The one thing you will see change is that GitHub's offering a package registry now. So there'll be a way to publish packages on GitHub as well. They don't support Python right now. I'm not really sure, actually. I mean, they're GitHub folks here. You can ask them about it. Maybe it'd be better to talk to them about it. But yeah, I mean, I don't think PyPI has any plans to change the way we do installs now. Yeah.
Okay. Thank you.
Thanks.
Great talk.
Thanks. Any other questions? Yeah, let's get you the mic.
Hand. Where?
Hey, so I was just wondering, you mentioned there are some differences between how you manage your workflow in a application, whereas in a library you do some things differently.
Yeah.
You might not use Docker, for example, I think. What are some other things that might be different from a library?
Yeah, great question. So I mentioned before, I'm mostly talking about applications here, because PyPI is an application. The question is, like, what is the differences when you're developing a library, right? So I think the biggest difference is, I said that we were confining our application to a single version of Python and a single platform. When you develop a library has to work across a broad range of versions of Python and a broad range of platforms. So this creates basically a whole bunch of extra infrastructure that you need to build around your testing environment. You need to be able to run tests against an old version of Python, the most recent version of Python. You need to be able to test on like Mac OS or Windows or whatever, however you want to support. And so Docker, you can't run a Mac OS container, for example. You can really only run like a Linux container. So when you're testing a library locally, you need to use like multiple CI services to test against multiple platforms. You need to use CI like Travis. So Travis is basically using multiple Docker containers to run your tests in Python 2, Python 3, whatever. I think there's also sort of a different dependency workflow here, right? But yeah, basically those are the big things. It's like you go from being constrained to a very specific environment to a huge, broad range of environments. And then this workflow basically starts to break down. Yeah.
Thank you.
Yeah. Another question?
Just
How do you split the different environments, the different requirements for your environment in your development process, like dev, linting, or I don't know?
Great question. So yeah, my example was pretty simplified. The question was, how do you split up different types of requirements? So my example was simplified. I just had a single requirements.txt file. But yeah, if you wanted to test, right, you're going to introduce dependencies like PyTest and things like that. And you don't want those to actually get deployed into production. You only want those deployed in your test environment. So for example, what we do with PyPI and what I would recommend everyone do is you can create multiple files. So even if you're compiling dependencies from in files, you can create like a test.in, main.in, deploy.in. That's what we do for PyPI. Those all get compiled to requirements files, and then you can optionally install those depending on which environment you're in. So for example, like maybe you'd install all your base dependencies that your application is going to need no matter what, and then only in the test environment install the test dependencies. And I think a lot of people also don't know this, but requirements files can recursively include each other as well. So you can include one requirements file inside of another one. So it makes it pretty nice because you don't have to reproduce the same dependency across multiple files. Does that answer the question? Yeah.
Yes.
I can show you an example afterwards too.
What do you think about the PyProject.toml or something?
Yeah. What do I think about PyProject? How much was that, Oscar? How much time do we have?
that's the last question.
Okay, last question. So who's heard of PyProject.toml? Yeah. So this is a configuration file that some Python tools are starting to use. It exists to solve a pretty complicated problem, which is that setup.py is not a great way to configure a Python package. I think it's great. It's solving a problem that's a subset of packages have. I think for most people, you don't need to think about it too much, right? If you are building a Python tool and you want to have a way to configure it, you should use PyProject.toml. But otherwise, it's probably not on the radar for most people, and you don't need to think about it that much. Yeah.
Thank you very much.
Thanks, everyone. Appreciate it.